very important session. This session is, not easily delivered in Indian context. Whenever we think of landfill and land management related issues in the context of municipal solid waste, we often think of some international experience, US experience. We think of some European, limited to some extent European experiences, but very few experts are there in the country who can handle this session, both technically as well as administratively. Yes. As we discussed last time, we have covered the whole sanitation service chain from starting from segregation onwards, all the way. Now we have come to the last component of the sanitation value chain, which is about disposal on land in a secured and safe way. So to discuss this subject, which is super important for all of us, because as I said, this technical and administrative understanding of this subject is very limited with select people. So we thought we would invite again Ravi Kant sir for delivering keynote address and set the context. And all of you have met Mr. Ravi Kant sir on day one of the course. He has given the inaugural session, and he has also given a complete perspective on municipal solid waste in an integrated context. Today, we have requested him to cover this subject, which is, as I said, is very, very important from practitioners' point of view. Many a times, a lot of concerns are there, a lot of NGT cases are there because of unsecured management of landfills. So we need to avoid it at any cost. So today's format is that Ravi Kant sir will lead the conversation as a keynote speaker, set the context, explain in detail. I have seen his PPT. It is such a delight to go through it. You can't find this in textbooks. I now invite Ravi Kant sir to deliver the session. As all of you know, he has seen this sector in a 360-day perspective as a senior IAS officer, a member secretary, Pollution Control Board. On one side, he has seen as a director of Ramki, managing director of Ramki, and a project lead of Hyderabad project. And he has seen both in advisory capacity, and most of the IAS officers in the country who are associated with this are mentored by him. So I'm very, very happy and fortunate that he has taken out time to interact with us. Over to you, sir.
Good. So, good evening, friends. I'm so happy to connect with you all over again. Ultimately, the waste has to get some resting place. We should try to 3 hours, 4 hours, 5 hours. Ultimately, if we cannot do anything about the waste, it has to be put or stored somewhere very safely. And that is the last point, cradle to grave. That is the grave of the waste. And that is called the landfill. But before, friends, I must tell you, don't call it landfill. Landfill means dump, dher. We should call it secured landfill, because what we are discussing is secured landfill. And if you see, Professor Chari has written the topic very beautifully so that there should not be any confusion. What he has written, inerts. He has used the words inerts. Why I'm telling you, I'll explain it later. He has not said the landfill for waste. He has said for inert waste. Why he has said so? There is an Indian context to it. There is a reason, a logic to it. I'll come to it later. Okay. So friends, before I actually start any presentation, I always assume that maybe some of you are not exposed to these concepts. So it's my duty to sort of recap what is organic matter and what is decomposition. So let me first discuss, just for your understanding, what is the meaning of decomposition of organic waste. So any organic matter, friend, when it dies, it will break up into a simple matter. Simplest definition, that is called decomposition. When we say do not use plastics, means what? It does not decompose practically. Therefore, we say that avoid plastics. But organic matter will decay once it dies. What is organic matter? We are organic matter, fruits, vegetables, all restaurant waste, everything is organic. And when it is dead, it dies, it starts decaying. And I told you jokingly, why do you keep refrigerator in the house? Because you are only storing dead bodies in the refrigerator. Bhindi, aloo, pyaj, sabji, chicken, all are dead bodies. Why are you keeping in the refrigerator? Because since the temperature is less, therefore the decay is not very fast, so that you can still consume those dead bodies within 2, 3, 4 days. But I suggested don't keep things in the refrigerator for too long. Try to use and consume ASAP. Okay. Now, friends, God, when they created Earth, they were very conscious that the human beings will come, and we need to create a system by which the organic matter should decay automatically. Therefore, this decay is actually facilitated by microorganisms, and which are present in our earth, in our ecosystem, in our soil, in our water. They are there everywhere. So this organic matter will decay in two ways. In presence of oxygen, we will call it aerobic decomposition. So oxygen means what? It will take it from air, and air is 20% oxygen. And the microorganisms chiefly, which is bacteria and fungi, these bacteria will use oxygen and feed upon the organic matter. And that is how the organic matter will start decomposing. And ultimately, there are many stages, but let's not go into organic chemistry today. This organic matter ultimately will convert into carbon dioxide, ammonia, water, heat, and compost. And as I told you last time, friends, compost is not a fertilizer. You know that. Okay. Compost is not a fertilizer. Please remember, it is only a soil stabilizing agent. It creates gaps and pores in the soil, so that when plants are growing, the aeration is facilitated, the water intake is facilitated. And if you keep the organic waste in a watertight container, airtight container, it will still decay, and that decay we call it anaerobic decomposition. And here the waste will decay in absence of oxygen. And again, there are organisms, methogens, which I've underlined. These will break down this organic matter into an end product called methane. And you know, methane is a very deadly greenhouse gas. It has 24 times more powerful in creating greenhouse effect than your carbon dioxide. Municipal waste dumps contribute quite a lot of methane in our ecosystem. And then there are traces of hydrogen sulfide. All this bad smell which comes, you know, when you go to a dump. I'm not talking of a landfill, secured landfill. When you, because mostly Indian cities, you know what they do? In the name of waste management, they will collect and transport garbage, and finally they will dump the whole thing just outside their welcome gate in somebody else's land. So that is called dump, where this hydrogen sulfide and methane are all getting produced. So this is the concept. I am sure why I've given this, so that you know you will be able to appreciate the topic in a much better manner. Now I'll just briefly touch upon the concept of the waste management: reduce, reuse, recycle, recover, dispose. So I am not going in the details. As good human beings, as good citizens of this earth, we should explore all the options of recycling, recovery, and etc. When all options are exhausted and nothing can be done with the waste, and the definition of waste is a material which has got no use for human mankind, but that waste could be very toxic. It could come in contact with air, water, and soil, what we call environment. So it has to be then safely disposed, or else it will disturb the environment. And the scientific disposal of the waste is done in two ways. If you recall, I had told you that one thing is certain: we may be very good, we may be very bad, we may be rich, poor, beautiful, not so beautiful, but Common thing is all of us are going to die one day. Don't feel sad. This is a hard fact of life. Therefore, enjoy life till you are alive, till the last day. But if we are lucky, somebody will bury us or somebody will burn us. Similarly, all the waste in the world which has got no use to human mankind is either buried or burnt. So today our topic is only burial. Next time when Professor Chari gives me an opportunity, I will talk of incineration. It is very difficult, but since we are doing this incineration in Hyderabad, so maybe an opportunity comes, I will talk about incineration of waste, because this is going to be the future of the country. Okay, Barry. And remember, whatever we do, landfill, incinerator, it has to be done in a manner that again in that process we should not disturb the environment, that air, water, soil are not affected. So roughly the recyclables form 30% of the Indian waste. The good news is, though we do not have efficient system of collection by Sarkar, however, this rag pickers and private interests, they are collecting it at some or the other point in the system. Organic matter, the green waste is 45%. And now I need not explain, therefore I created the first slide to elaborate on this point. Now the question arises that God has created this process of decomposition, both with oxygen, without oxygen. The only thing we the human beings need to do, that these processes should be done under our control. It should not allowed to happen by itself, because if we are doing, let us say, decomposition of the organic waste, in absence of air, methane would be produced, it will go in the air. But if I can produce methane and capture it, I can use it for, as a fuel. I can use this for lighting my bulbs, etc. Also, I can use methane to run my power plants. Let me tell you, in India, we are only supposed to put inert material in the landfill, secured landfill. Why? Because even in the inert material, there are traces of organic material. But abroad, what they are doing, they are putting the entire organic material in the landfill inside. Methane is getting generated at such a pressure and such a rate that that is good enough to power the electricity producing plants. Therefore, but in India, we do not allow the anaerobic landfills. That's what I'm trying to say, because it is very difficult to construct and more difficult to maintain. It can cause accidents. So when we talk of secured landfill, we are only talking of only putting the inerts. And what are inerts? You know that. So when we actually convert the municipal solid waste, or you have all learned by now very well, when we process the waste at our site, we convert the organic fraction into compost, which is called aerobic, through the aerobic decomposition. And we can also resort to biomethanation for waste from the market yards or sabji mandis, because unfortunately fact remains, in India waste is not segregated, and it will not be segregated till there is a political will. Administration is all prepared to do that, but since there was a political will for 2 years, after that it subsided. Inerts actually comprise of 25%, and mostly these are the rejects of composting. Currently in our country, slowly and gradually, big cities are getting into collection and demolition, collection, etc. Therefore, that percentage is reducing. And at the disposal sites, it is the inerts which are 25%, which need a place to store, because we cannot do anything about that. So this is what is deposited in the sanitary landfill. Therefore, we need landfills. Now let me give you some international flavor. If, friends, our waste was segregated, then what? Then, like, I had a good fortune of training in Germany for 2 months for this scene only. I went to a place where they had a plant for 300 tons per day capacity, right? And they were getting the pure organic waste there, and whole of it was getting converted to compost. Since there were no contaminations in that organic waste, trust me, there was nothing which had to be deposited as inerts, almost nothing. So you can call it, they do not need a landfill. Or if at all they need, there is a regional landfill some miles away. So maybe in the entire province, one landfill is good enough. Okay. And the best part was there was a queue of people. I was curious to ask, why are these people queuing up in a waste management plants? Then I was told they are all farmers and they are very eagerly waiting to collect the compost which is being sold at the gate. So they wanted to collect it fresh. So I pray to God that we come to this stage in the country one day, but it can be tomorrow, provided we segregate the waste. In that case, organic waste will convert entirely into compost, leaving no scope for any inert, therefore no landfill, therefore zero landfill. Because landfill is a liability. Why? Because you are blocking the earth, its area forever. So we should not encourage landfills, but it is a majburi. It is a necessity. It is a necessary evil. Though we are making money by making landfills, operating, but you know that money is not important. Mankind is more important. So hope you get the message. So ultimately, I told you whatever we discuss, that's fine. But waste segregation ultimately is the key to waste management. What happens now? You see this beautiful picture. They are, this is a garbage dump, friends, dump. And what is happening? It is a potential fire risk. Now you know why there is a fire risk, because the waste, including organic waste, is dumped inside, no access to oxygen, produces methane. In any spark, that gas, methane, will flare up and there will be a fire all around. And all are these, birds and rodents, they are feeding on the waste. What a dirty sight, very common in India, including Delhi. So methane is stage 4. Now you can see this is a picture of erstwhile Hyderabad before we from Ramki stepped in. So this is how the picture was. Can you see? It is a hell. If you have to describe Nark, this is Nark, hell. And then you see these are the upper reaches of the waste. And here the fire is raging like a furnace fire. You can melt iron here. Not only fire, friends. When the water, the rain and precipitation falls on these mountains of waste and there, so all the toxins of the waste and the water and everything gets combined to make this river of poison, pure poison. And this will create irreversible damages to people's health and all sorts of problems. So this toxic liquid, leachate, is flowing in a system. And now it is a composite picture. What a beautiful scene. The burning mountains and the rivers of leachate. Other day I was telling Professor Charya, I was in Nagaland, lovely mountains and clean waters. Just contrast burning mountains and rivers of leachate. This is our municipal solid waste management. This was once upon a time, but now Hyderabad waste management project was given to us in the year 2009. And this is the biggest and the best project in the country today, treating 6,000 tons per day. I was the project director of this project for 3 years. And I know most of you have seen this video, but this video has to be seen by you again, 11 minutes only. Why? Because it covers the entire waste management operations, what Professor Chari is endeavoring to teach you in just 11 minutes. You can see what we call cradle to grave cycle. So over to you, friends.
Hyderabad, endearingly called the Pearl City, is one of India's fastest growing cities. Today, it has emerged as a strong industrial commercial technology center and is seeking to be a globally preferred destination. As human needs and activities overload our planet, many countries have introduced statutory waste minimization and recovery targets to address the Earth's dwindling resources and the growing mountains of waste. The population growth, rapid urbanization, and the changes in the city of Hyderabad has seen coming of the Greater Hyderabad Municipal Corporation. The Greater Hyderabad Municipal Corporation, or GHMC, is the local government for the cities of Hyderabad and Secunderabad. Improper management of municipal waste by disposing it unscientifically into open dumps and landfills is creating huge problems to public health and environment. With a commitment to better the environment and to provide the best sanitation services to the citizens of Hyderabad, Ramki Enviro Engineers, a pioneer in waste management, has established a quality delivery system, the Integrated Municipal Solid Waste Management Project. The HIMSW project uses the most environmentally sound strategies for municipal solid waste. Scope: door-to-door collection, secondary transportation up to transfer station, transportation from transfer station to processing and disposal facilities, processing and disposal, transfer stations, reclamation and alternative use of existing 4 dump sites, components, compost plant, refuse-derived fuel, waste to energy, landfill operations, capping of existing dump, leachate management. The waste transported from the transfer stations is brought to the facility where each truckload is weighed and data entry is made using computers with data servers for storing, retracting each entry. The weight trucks offloaded at the tipping floor of pre-sorting unit are loaded onto conveyors using dozers. The waste is passed through a 100 mm rotating screen or trommel with screens of 100 mm sieves. The recyclable material, like plastic bottles, is recycled at a recycling plant inside the facility. The material besides the recyclables, with size more than 100 mm, is known as combustible material due to high calorific value. Refuse-derived fuel. The segregated combustible material is further processed to get refuse-derived fuel or solid recovered fuel. The combustible material is stored on a dry concrete platform to ensure maximum moisture removal by sun drying. The dried material is fed to the hopper of a primary shredder, where the material greater than 100 mm is shredded to 80 to 100 mm material. The primary shredded material is fed to the hopper of a secondary shredder that reduces the material size to less than 25 mm. The secondary shredded material is then conveyed to a baling machine for packing the material. These bales are then stretch wrapped and transported to cement industries as fuel. The segregated material passing through the 100 mm sieves of trommel are further processed using windrows process. The windrows are turned for 28 days to ensure complete exposure of organic material to oxygen. The windrows are sprayed with herbal sanitizers to ensure better decomposition and ensure no odor is generated. The material from the windrows section is further refined by passing it through rotating screens of 35 mm sieves. The material with size more than 35 mm is segregated, which can be briquetted and used as an alternative fuel to fossil fuel in energy-intensive industries. Material less than 35 mm is further screened using trommels with screen or sieve size of 16 mm. The material with more than 16 mm size is segregated and briquetted for cement industries as fuel. The material less than 16 mm is stored in the curing section for final screening and curing. In the curing section, the output of 16 mm screening is sent through final set of screens or trommels, which segregates materials less than 4 mm. The final output is refined, which meets the fertilizer control order standards and is used as biofertilizers in agricultural sector. The final output is further blended with additives to improve the product value and packed in a blending and packing shed for dispatch to fertilizer companies. Other recovered products include coconut coir pits from shredding of coconuts. The coir is baled and sent to small-scale industries and as fuel to factories. Waste to energy. The waste from the trucks is tipped in a storage pit. The storage time for the waste is 7 days with leachate addition for charging the waste. The charged waste is fed to a hopper using cranes. The waste is then passed on to moving grates that combust the waste at a temperature of 1100 to 1200 degrees centigrade. The engineering design of the furnace ensures that the intermediate gases go through complete combustion to maintain a temperature of 850 degrees centigrade. Maintaining this temperature ensures that dioxins and furans are not formed in the process. The heat energy is passed into a boiler for generating superheated steam. This steam is used for driving the turbine and electricity generation. The electricity generated is exported to the grid after captive consumption of 15 to 17% of total electricity generation. The residual gases from the process are passed through air pollution control system, which comprises of scrubbers for removal of acidic gases such as nitrogen oxides, sulfur dioxide, hydrochloric gases, any heavy metals, and activated carbon filters. Any particulate matter is removed by using dust collector systems and precipitators. The bottom ash from the incineration process is removed and can be used for construction purpose. Landfill. The processing of waste generates various byproducts. The inert material that is essentially present in the waste or is a rejected material of the process is disposed to a secure landfill. The landfill comprises of multiple layers of boulders, clay, HDPE sheets, geotextile, and leachate collection network of HDPE material. These layers are of varying thickness to ensure that no leachate from the landfill percolates the soil and groundwater. Landfill operations are closely monitored to record any leachate movement. Capping. The existing site for waste management facility has the legacy of years of waste dumping. The waste dump is capped using scientific methods. The process requires laying of HDPE piping network for collection of leachate, covering of soil followed by clay lining, geocomposites, additional thicker soil layer, and vegetation cover. Piping network is also laid for collection of any methane gas and flaring to mitigate release of greenhouse gas emissions. Leachate management. Leachate management is a crucial aspect of the HIMSW project. All the waste stored and waste management processes generate leachate. The leachate generated at site is collected through an extensive pipeline network. Raw leachate is pumped to a chemical dosing tank with flash mixer. Alum or coagulant is added to the tank to create flocks from the suspended solids in the leachate. The leachate is passed into lamella settler that settles the flocks of suspended particles. The supernatant is passed through pressure sand filters that remove the remaining suspended solids and reduce turbidity. The leachate is then passed through a two-stage reverse osmosis system, which uses membranes for filtering the leachate of all contaminants and provide clear permeate, which is used for greenbelt and landscaping development. As we do our bit for the environment and for the generations to come, we strive to deliver service excellence to save natural resources, conserve energy, reduce pollution, reduce the toxicity of our waste, and save money for consumers and businesses. The project is a model for inclusive and sustainable development for our society. HIMSW extends the vision of Ramki Group towards sustainable development.
So friends, hope you like this presentation, and this explains the entire life cycle of the waste. And I am using these terms, secured landfills. I'm sure all of you are listening to me and your chat boxes are ready. And engineered landfills. Can anybody tell me the difference between all of this? Anybody? Write on a chat quickly so that Pratibha can convey it to me that somebody has found a difference in any of these. These are the four adjectives which we are using in the system. So I thought before you get confused, it's my duty to demystify these four adjectives used before landfills. Pratibha, any answer from anybody? Anybody know what any difference between amongst all these four names?
No answers yet, sir.
Because they are all very wise people, all are same. There is no difference. So friends, so what I'm trying to tell you that you will come across these terminologies. These are all same. Secured, sanitary, engineered, scientific. So now, as I told you that the disposal options, either you burn the waste or you bury the waste. So I will only cover half the portion today, burial part. Burning part maybe later. This waste material, which is of no use to human mankind, has to be deposited somewhere which is sealed pocket, and we will create the sealed pocket inside the earth. What is this? It is a system where the waste is jailed for 1000 years, 2000 years, till the earthquake comes and everything gets dislodged. Since the waste is jailed, it will not be able to come outside and interact with good citizens like air, water, and soil. And it has to, and no waste liquid will be allowed to percolate and pollute our groundwater, surface water, etc. And there cannot be any gaseous emissions which will be adding to the greenhouse load of the planet. So friends, I am giving you a very simple diagram, most simple. So this is a secured landfill. So this is lining that everybody talks of HDPE. HDPE is a plastic which is called high density polyethylene, just a plastic. These sheets are used which do not allow any passage. And below that, this black thing you are seeing, this is a clay layer, 90 centimeter thick clay layer. Why clay? This black soil is called clay because clay has a property, it is highly impermeable, and there is a mathematical coefficient of permeability. It is 10 to the power minus 9 meters per second. So this very highly impermeable, and for a double protection. And then is a simple diagram. I'll come in details later on. All the waste is filled inside, and finally we cap it, and we see to it that gas doesn't go outside. It has to be captured, and leachate does not go inside the groundwater below here, and it does not disturb the surrounding geology, earth, etc. So this is the simplest diagram. I'll make it slightly more complicated now. So here, if you see, this is the our land, and here we are making the landfill here. This is the clean surface water which cannot be disturbed. So this is a liner, flexible barrier means HDPE, and this is the landfill isolated waste you can see which is jailed, and there is whatever gas, because you know, as Professor Chari wrote in the topic inert, we are putting inerts, but also some organic fractions, etc., ultimately go, and some gas will be produced. So whatever methane is produced, since it is anaerobic decomposition, no oxygen inside, so that gas will escape here and will be collected. And since it is already covered, so there will not be any dust, litter, pests, rodents, etc. And it is having a slope, so that any rainfall coming, the water will go and will be collected in the drain. And all the dirty water, in case of course it will be there, and with the gravity it will flow, and we will collect the leachate also, right? So this is another diagram. I will now come to the concept of a landfill. It is a 2.4 minutes video, and whatever I have talked in English so far, of course they will also talk in English only.
So how does a modern landfill work? Imagine a giant plastic bathtub in the ground. Trash is added to the open tub and covered each day with daily cover, such as contaminated soil or ground-up construction debris. As time goes by, more and more trash is piled on, and more highly toxic methane gas builds up as the trash decomposes. This is when you start to get that trash smell. You know the one. Any water that's in the trash, or any rain or snow that seeps through the cover, starts to trickle down through the garbage. When water and waste are mixed, it creates a toxic, poisonous soup called leachate. Leachate contains all the dangerous stuff that's in a lot of what people throw in the trash. The tens of thousands of chemicals, heavy metals, and other toxic materials found in electronics, batteries, prescription drugs, and plastics, just to name a few. Now the leachate, containing these poisons, percolates through the trash and eventually pools at the bottom. One set of pipes collects the liquid and takes it to the collection tank. And another set of pipes collects and diverts the toxic gases. However, only some of the gas gets captured over the life of the landfill. The rest escapes into the air, rancid odor, and airborne toxins that have been shown to travel over 3 miles from a waste site. History has proven that many parts of a landfill system will eventually fail. The collection pipes buried under the garbage will become clogged and eventually break. Liners will be punctured by sharp objects, and the chemicals in leachate will burn holes in the plastic. Even the EPA and Casella's own experts admit all liners leak. If a leak were to be detected, it's too late. You cannot repair a liner once it begins to leak. Small holes become big holes, and eventually the barrier between the waste and groundwater completely fails. How and where the leachate will reach the groundwater is impossible to predict. Hundreds of homes using private wells surround the Southbridge landfill. The next time you take a sip of cool water from the faucet, bathe your kids in the tub, or take that long run in what you hope is healthy fresh air. Think about it. Dirty diapers, broken office furniture, bathroom cleaners all sound harmless enough when you're chucking them into the trash. But now you know.
So friends, it's another important message which I want to deliver. The truth of landfills, secured landfills, is that all landfills leak. It is a fact. Because over a period of time, no matter how much care you take in making and operating the landfill, but at the end of the day, there will be some leakage. And now it depends upon our skills, human engineering, that how the landfill, what integrity level you make. So therefore, the message is we should avoid material to be landfilled, and we should aim towards a zero landfill. Of course, it is quite number of years away. Now coming to this, whatever was explained again, so you can see this is the landfill which we have dug, and here the leachate is pumped out through submersible pumps. It goes in a leachate pond where further treatment and all. Whatever gas produced, very little quantity because it is all inert, so it escapes or it is flared or it is captured. And you can see this is the upstream, this is the downstream, and we are always checking the water quality upstream as well as the downstream to see whether this landfill has got integrity. If it leaks, then the water quality here will be definitely worse than this, and then we can find out whether the landfill has been made properly or not. So this is the another diagram. Now let me make it slightly more complicated. So friends, in a scientific landfill or a secured landfill, you can see the clay liner at the bottom. Then this is another whatever liner I was talking. Then we put this is actually the in situ site clay. We put the this is our clay which we put and compact here. Then all the leachate of this waste which is now captured inside the landfill, this leachate collection pipes are there. and you will well imagine these are all perforated pipes. These pipes will rest in a gravel medium, so that there is no hindrance to the water flowing out of these pipes, leachate, so that can be collected. We'll go in the details later on. And then there are geotextiles to see that the HDP liners are not punctured. So as a protection between the this media and the liner, we put those geotextiles. Then you can see this gas collector. Gas is collected from the landfill and it goes to the collection. So this is another good diagram I thought I'll share with you. So I just spoke about how the gases, because in a landfill, the trick is you should keep collecting the leachate which is generated as quickly as possible. Because in the previous video, if the leachate remains for too long here, then it will generate hydraulic pressure on the liners, on all the material here, and then tend to create holes and leak here, which is very bad. So we must evacuate the leachate as soon as it is produced, and also evacuate the gas. So how are these drained out from the landfills? Now I will invite you to a 1.5 minutes video here.
We all know rotting garbage is stinky, and it's even worse when it gets wet. So you can bet the stink is sickening when it rains on a 100-foot-tall mound of rotting garbage. Of course, that happens a lot at landfills here in southeast Louisiana. When it rains at any landfill, water seeps down through the grass and earth, through the garbage heap, and collects on the bottom. So do liquids that ooze out of the garbage when it decomposes. All that liquid is called leachate. As the garbage decomposes, it emits gases like methane and CO2. A layer of gas forms on top of the leachate. Landfills have a system to collect both the leachate and the gas so they don't contaminate the environment. Pumps send the leachate to retention ponds, where it's treated and stored. There are also vertical gas wells running down through the landfill. They use vacuums to collect the gas. Different pumps inside those wells send the gas up and out to a gas plant, where it can be processed and sold as usable natural gas. Now, if these pumps are working properly, there should be only 1 foot of leachate under that 100-foot mound of garbage. The vacuums that suck the gas into the wells sit right above that normal leachate level. But if the pumps are not working, like they weren't at Jefferson Parish landfill for years, the mound of garbage becomes flooded with leachate. That flood of leachate can block the vacuums from sucking the gas into the wells, and now that layer of toxic, smelly methane and hydrogen sulfide isn't being collected anymore. Instead, it rises up through the landfill and escapes into the air.
By now you are, at least you have understood the secured landfill purpose, design, everything. And now whenever we have this waste processing plant, obviously there would be rejects. I am not talking of RDF, I am talking of rejects. So those rejects will have to be managed in a secured landfill, and as I told you, it is a necessary evil. And a fully integrated secured landfill will give you these benefits from measures. It will protect you from groundwater pollution, surface water pollution, air pollution, soil pollution. So for me, environment is always number one: air, water, soil. Now we will come to fire hazard will not be there. Birds menace, obviously, you have seen in the pictures before. Pest, rodents, greenhouse gases, methane, and dust, wind blown litter, bad odor. And of course, whenever, let me also tell you something. When you start putting garbage in a heap, like in Delhi or any big cities like in Mumbai as well, so there is a thing called angle of repose. You know, angle of repose is an angle. If it goes beyond that, then the whole slope mountain will come crashing down. So those garbage dumps are also prone to coming crashing down and, you know, engulfing the entire hutments, etc., and of course erosion. So when you mix a landfill, all of these problems are taken care. Okay. Now, what are the essential components of a secured landfill? As you have seen, there has to be a liner system at the base and sides of the landfill. Then leachate collection, gas collection, and once we have closed the landfill, there has to be final cover. Then surface water will come, so drainage system and lab for environment monitoring and closure and post-closure plan. These are the requirements at the site when we have a secured landfill facility. This will have office, laboratory, workshop, because a lot of heavy equipment is there. So repairing and all the weighing scale, then treatment facility, then you have a proper fencing so that people should not, it's a very dangerous facility. So stormwater drains, and then areas for holding the waste material. Of course, there will be a construction materials as well. Then environment. These are the basic minimum things which are required in a site where this landfill management is being done. So friends, what is the life of a landfill? So design life of a landfill is equal to all these four items. One, construction period of a landfill, let us say 1 year. Active period will depend upon the site, the area and the waste. So typically 10 to 25 years. Then finally, when the landfill capacity is full, you have to have a proper closure. And don't you think that once I've capped everything and the pollution control board has tested water quality, gives you a certificate of excellence? No, nothing. Problem is, as I told you, all landfills in the world leak. Let us accept it. So the real test and integrity of the landfill made and engineered by you will be known later. And for next 30 years, you have to keep checking the water quality and air quality and all those things, So landfill itself is a very big liability. And so now we will spend some time on construction and development of secured landfill. You have seen in the videos, they have shown many layers. They are showing clay, they are showing HDPE, high density polyethylene, etc. So let me tell you one by one. सबसे नीचे सबसे पहले होता है well prepared sub base. The natural earth, you have to prepare the sub base. Then you have to put a clay liner which has to be compacted, and as I told you, the coefficient of permeability of clay liner is 10 to the -7 centimeters per second or -9 meter, on the same thing, and it has to be 900 mm or 90 centimeter thick. This is the requirement as per Indian law. The HDPE liner typically has to be 1.5 mm thick, and then there is a drainage layer. Drainage layer means there is a gravel media within which the perforated pipes are embedded in a network. So all the leachate flowing down from the waste above will be flowing through these pipes network and ultimately would be pumped out. And of course, then there's our great enemy waste, which would be occupying the entire area inside. And after waste is done, then we again put a layer of compacted clay, then again a drainage layer, then again a gravel media, loose sand, and finally we put a vegetative cover. We will put earth and soil, and then we will grow some grass and all. And to any outsider, it will just look a beautiful mound of grass. Unfortunately, this landfill mountain cannot be used for any productive purpose. It can be at best used as a recreation park, or even children are allowed to run over it, no issues. But then you cannot make any, because it is all waste inside, no? So you have to, now, whatever I have said so far, I will explain in a diagram. So first component, you can call me back, no problem. So first is subsoil, then this is the compacted clay layer, then 1.5 mm thick HDPE. Then there is a gravel media within which these perforated pipes are placed so that, the water can, the leachate can come out freely. Then the whole waste is deposited here, and finally another 60 mm of compacted clay, then again drainage layer, then vegetative cover, and over that is how the landfill gets closed. One thing which I have not shown here, friends, between HDPE and gravel, there is another fine geofabric, so as to prevent the sharp gravel damage in the HDPE. So that is a small thing. I don't want to make it complicated, because The principle is we should make our life simple in house, in office, generally, and remain happy. If you make complication, you will be unhappy person. Now let us have a small video, 2.5 minutes of whatever I have explained. We will see that. Okay. So, friends, you've seen the video. When we operate landfills in our sites, we do not operate the whole thing at a time. We have phases. We earmark the land for landfill, and then we operate in phase 1, 2, 3, 4. And again in phase 1, we operate cell by cell. So today's waste, when we dump and then we compact it, and over that we have to put a soil cover every day so that rodents and all other things, there is no disturbance. So this is what we will see that thing in some detail later. But now let me tell you through pictures the stages. These are all taken from our site. So there is a land excavation on a massive scale. And after that, this clay liner is being, this clay black soil is being put and is being rolled. And then clay lining has been done here, and now this landfill is ready to receive. This is in Dobaspet, Bangalore. So this is ready to receive the HDPE. So now this is a HDPE. You can see the huge area and the size of the lorry here. So these all HDPE, high density polyethylene fabric has to be spread. But you must be wondering that there are two fabrics. So where is the jointing? How is the jointing done? Because this jointing is a very great engineering art and skill. It has to be done through a hot wedge extrusion welding. Now you can see this is being, the HDPE liners are getting welded. So it becomes seamless. It is very important. It is done by trained people only. And finally, the drainage media, filter media water on the leachate pipe. So these are the over that HDP, this is all is being put. And then we have to now see how we operate the new cell construction. It is a small video of 2.5 minutes.
In this video, we're going to show you the actual construction of a liner. So you're going to see these different components being actually built in the field. Good morning, folks. My name is Hank. I'm the director of the La Crosse County Landfill. Have you ever wondered what's at the bottom of a landfill that protects our groundwater from becoming contaminated? When water gets into a landfill, it produces a liquid called leachate. And we don't want that to get out of a landfill, and so we put liners at the bottom of a landfill. But a liner isn't just a simple piece of plastic, it's many different components. A modern landfill has a very thick layer of clay, 4 feet in thickness, and then has a synthetic on top of it. So as you look at a liner, all this is clay material. It's 4 foot thick and it's very carefully placed. Above that, we put a synthetic layer made out of high density polyethylene. And above that, we put a fabric to protect it from punctures. The liquid has to be collected. It can't get through the liner. So we put special layers of rock at the bottom of a site, and we put special pipes in the landfill site that will take that liquid out. We're at the base of the landfill right now. This is the fabric that's protecting the synthetic, and below the synthetic, there's 4 feet of clay. This is the gravel that's being put on top of this now. They'll thin this layer out to 1 foot thick. And I'm now in the trench where we're gonna put a pipe that's gonna take the liquid out of the landfill site. I'm on top of the synthetic liner and the fabric, and we'll put a round pipe in here that goes the length of this trench, and we'll bring over some more gravel so that the whole base of this landfill site will let the liquid go into the pipe. That can be taken out so it can be treated at the La Crosse County Sewage Treatment Plant. So you can see that a liner is made up of a lot of components, specially built, carefully certified, approved by the DNR, and that's how we protect the groundwater that's below a landfill site. Thanks for taking a few seconds and looking at our videos.
So friends, I am now coming towards the end of the presentation.
Hello and welcome, learners. Today we will walk you through how a landfill works and what the inside of a landfill cell looks like if we were to cut it in half to view a cross-section. Now you may first be asking, what is a landfill cell? A landfill cell is a well-built, well-engineered hole in the ground where trash is buried. A landfill can have several landfill cells over its lifespan. As you can see here in the aerial map of our Iowa City landfill, we have several different landfill cells over the years of operation, which is since the early 1970s. Each cell is named for the year it was constructed. So for example, FY02 means that the landfill cell was built in the fiscal year of 2002. Today we will focus on just one landfill cell example, starting with what an active landfill cell looks like. An active cell is a landfill cell that is still receiving trash. So trash trucks empty their garbage loads into this hole, and we have our trained landfill operators actively working in this hole to compact and cover garbage. Up next, we will show you what a closed cell looks like, which is a landfill cell that is full and must be securely covered and closed. But for now, let's get into the specifics of an active cell. The image we are looking at here shows many layers in this cell. So let's walk through each layer from bottom to top. Starting at the bottom, we have the groundwater layer, which is water deep underground, followed by the normal subsurface layer, which is what we dig into to construct a new landfill cell. This consists mostly of topsoil, sand, and clay. Once we have the right-sized hole dug and compacted, the next step is to line the bottom of the cell with 4 feet of clay. Why do we use clay? Well, clay does a very good job preventing liquids from flowing through it, or in other words, it is not very permeable. On top of this clay layer is a black layer that you see here, known as the flexible membrane liner. This is a very well-engineered and strong plastic liner that seals the base of the hole with a geotextile layer that you can see here, built into the liner along the bottom to assist in filtering sediment. The clay and flexible membrane liner work to keep the leachate and garbage securely in the hole to reduce impacts on the surrounding environment and local water sources such as groundwater and streams. Moving right along, we will now talk about these round pipes you see here that are surrounded with a layer of gravel. These pipes are used to collect leachate, which is any liquid that touches garbage, otherwise known as garbage juice. It can be anything from harmless liquids and wasted food to toxic metals like mercury or pesticides. Since it has toxic or hazardous materials in the mix, leachate can be harmful to people, animals, and the environment. Therefore, we collect leachate in these pipes and send it to the wastewater treatment plant to be treated. Liquids will naturally flow downward and eventually make it to these pipes to be collected. It is important that these pipes do not get clogged because that could impact the leachate being collected and processed. This is where the drainage layer comes into play. The drainage layer that you see here is made of shredded tires, and its purpose is to stop solid garbage from settling down any further, while it allows the liquids to flow freely down to the leachate collection pipes. Now, we have not even gotten to the garbage layers yet, and this is mentioned to emphasize how much engineering and construction goes into correctly building a landfill cell. Once all these layers are in place, trash can be landfilled in the cell. And we can see as we move up the cell, several layers of garbage. In reality, there would be many more layers filling a landfill cell. But for the purpose of this exercise, we have spaced out just a few layers to explain how this works. There is a green outline around each garbage cell, or each garbage layer. The green lines represent the daily cover, which is usually either a spray-on cover or dirt. A daily cover is added to the garbage at the end of each day to secure it in place, which means less trash potentially blowing around and less environmental impact. As trash continues to be added to the landfill cell over time, gas collection pipes that we can see here are laid horizontally in the garbage as needed. These are perforated pipes, which means that there are small holes along the length of the pipes to allow the gas to flow into the pipes. You might be wondering what types of gases we are collecting. There's a mix of gases that form in a landfill cell, which is an environment with no air or light. The gas we are most concerned about is methane, which is a strong greenhouse gas. We'll discuss gas collection more when we delve into the closed landfill cell next. As this is an active cell, there is still more room for trash, so the top of this cell is still exposed. Once the landfill cell is at maximum size and we cannot landfill any more garbage in the cell, that is when we need to securely close the cell. In this image, we still see all the layers and components we talked about in an active cell, but we see that some of these protective layers, such as the flexible membrane liner and the clay, are wrapped completely around the top layer of the cell with a 4 feet thick finished cover. Let's circle back to gas collection. With the closed cell, we can now see that there is a gas line connecting all the horizontal lines, which leads us out of the cell and up to the gas well. This pumps the gas, keeping it moving down to the trunk line, which transports the gas to the flare. The flare is where we burn the gas at a very high temperature, which converts the methane to carbon dioxide, a less potent greenhouse gas. On the top of the covered landfill cell, seed is planted so that a mix of grasses can grow. When a landfill cell is closed, it often just looks like a grassy hill. But as we have discussed, there is a complex system going on below the surface that continues to collect gas and leachate for many years after a cell is closed. Thank you for joining us today to learn about the inner workings of a landfill cell. We've been illustrating with mostly...
So friends, this was a very detailed video covering all the concepts which we have learned so far. Once the landfill is full, then we have to do the final capping and we have to close it, and that is how a capped landfill looks like. This is one of our landfills somewhere, maybe Hyderabad. So you can see these small gas vents, these are the small gas vents. And this is a capped and a closed landfill. And this does not mean the end of our duty and responsibility. For the next 30 years, we will have to monitor all the environmental parameters. Now, friends, let me थोड़ा पैसे वैसों की बात कर लेते हैं, because at the end of the day, we are all in business. Money is required. And anything, environment does not come for free. If you have to protect environment, you have to pay money. And who pays money? That is also very well settled. Polluter pays. The person who is polluting has to pay. So there is no doubt about that. Therefore, corporations have to pay because the citizens are polluting the environment, and citizens are paying how? The property tax. So I am giving you for the practitioners who are there in this meeting, these are very rough estimates taken on a generic site conditions, that in case you are having a 250 tons per day garbage, you want to make a plant, how much of acres of land you need for compost, for landfill, for greenbelt, for support in front, what's the total area of land? The greatest problem in India, and not a problem, a convenient excuse. Professor Chari, I'm drawing your attention. Everywhere you meet municipal commissioner, but poor fellow in commissioner has the average tenure of a municipal commissioner in this country is 14 months, because so many complaints against him and netas and all, he gets transferred. So nobody can really, ये नहीं जम के काम किया 3 साल, so then the things can be done. So the fact is, everybody is saying, Saab, I want to do waste management. What to do? There is no land. When you require, if you have to free at least 30 acres of land, you require for a proper waste management system. And I told you in the last lecture how to find land. And we found land. There is a land available in every city. If you have a question, I will tell you again, but I will not tell you now, because I'm sure you must have heard me correctly last time. I will find land for every city. You have a land city, but then you have to discover it. Okay. So let's talk about money. So friends, for a 250 tons per day, the project cost of a compost facility, the capital cost going to be 15 crores. Landfill 3 acres, I'm talking of phase 1, so much. Support infrastructure, so much. Total cost is 50 crores. So 565 crores. And secured landfill cost, the landfill construction cost per square meter area is so much. Operating cost, so much per ton of waste, and landfill closure cost is so much, 1100. And now I am going to close with a request to all of you to make our country clean and green. Thank you, friends, so much.
Friends, today we had a very intense session on landfill management, as Ravi Kant sir said, scientific, secured, SLF. So these are all the nomenclatures used, but primarily what we are trying to do is to contain the waste and ensure that, as he says, not an iota of waste goes and spoils the air, water and groundwater related issues. But as he also said, every landfill leaks. So we have to be super careful in following the proper specifications and design.
Friends, Typically, the landfill people who make landfills are not contractors, they are concessionaires. The DPR for municipal waste management can be prepared by a consultant, but they do not have the ability, number one, and also the time, and also the data, and also the primary data or the secondary data expenditure which would be required to be undertaken to make a perfect DPR, number one. Therefore, they would mainly concentrate on waste, characteristics of waste, how much waste, where is the land, etc., etc. And it cannot be DPR actually, not that they don't want to make it, but they cannot make it and they will not be able to make it within the money which is given to the consultant. Government or the corporation will not ask for a contractor, they will ask for a concessionaire. They will say, we need a concessionaire who will come here, establish the facility and be there for 30 years. That is how we are there in Hyderabad. Now, Professor Chari, your question answer starts now. Now that we have been given the responsibility, we have to go in minutest details. Soil survey, hydrological survey, which carries on for weeks together. It has to be done by the concessionaire, who will have to invest his own money and recover it in the next 25 or 30 years of the concession period. Are bhai, if you pay peanuts, you will get monkeys. There is a saying. So today in India, as per the Mehengai Index, the cost of collection and transport from house to house, depositing the waste to the processing site, the good cost where everybody is happy is 2,000 rupees per ton of the waste. And the tipping fees for processing and disposal is 1,000 rupees per ton of the waste. So end to end, 3,000 rupees per ton is required for a concessionaire to do the integrated waste management, so-called from cradle to grave or womb to tomb. Another word, womb to tomb. When you are polluting, you have to pay money, you have to pay price to clean the environment. Nothing comes free in the world. I am done. Now.
Thank you, sir. This has been a wonderful session. We have exceeded the time, but I think it's been a great learning value for me in particular, and I'm sure all of you. We have learned the nuances of landfill management, the risks, cost associated with it, and how much, what sort of precautions we have to take, not just during the construction, but also during operation and post-closure related project management issues. So with this, I would like to thank Ravi Kant sir. I would like to thank Kanath ma'am for taking out your time and sharing your knowledge and practical experience. As I said earlier, this is not available in books. This is only practitioners can share with all of you. And that's why we request time and again, we disturb practitioners like Ravi Kant sir as well as Kanath ma'am to share with you. And you're also practitioner at the city level. So this practitioners to practitioner interface is super important for knowledge exchange and making sure that we design and protect environment well.